Okay, let's begin with this question. Divisible pairs. Okay, Monica plus two favorite integers x and y that can be equal. They can be equal by has found an array A of length n. Polygraph considers it to be good as facing hills too. And let's begin this question. Hope we solve it within 2 hours or maybe let's have half an hour task if I just pay attention. Start with that. So given x and y, I just need to find pairs A of y and j such that A of a plus A of j is divisible by k by x, and I have to find pairs and j such that A of I minus A of j is divisible by y. Okay. Now, how can I group them? This is a called as a beautiful pair, and I need to find one of beautiful pairs. Now, given, let's take this test case actually. Yeah, it looks fine. Let's say I have 14, 6, 1, 15, 12, 15, 8, 2, and 15. Right? Now, where will I get A plus A divisible by x? When they belong to some modulo class x, and this belong to some modulo class n minus x modulo n, x modulo n. This both element give me a value just on dividing with x equals 0. That's the thing. So I need to group them based on the modulo classes. So let's say x is given me as 2 and y is given me as 3. Then we'll further group it into modulo classes of y. First of all, modulo class 0 and what elements are there in this. So it's so simple. Since we have 2, I just need to put all the odd elements here. 1, 15, 15, 15, fine. And here I'll be putting 14, 6, 12, 8, and 2. It's kind of 4 plus 5 if you have 9 elements. Now, whatever element I take, let's say I've taken 1. 1 plus 14 is 15. It's divisible by 5. Now, first condition is satisfied. Now, I need to make second condition satisfied. AI minus AJ is divisible by Y. So, when is AI minus IJ divisible by Y? When they belong to the same modular class. What do I mean is, let's say this is a modular class of 3, which contains, because answers will give 2 on divided by 3. I mean, modulo as 2. 3 by 8 modulo 3 is 2, and 11 modulo 3 is 2. So, when I just subtract them, I'll be getting a 3, which is divisible by the difference. So now, what all I need to just do is, I need to group them into modulo classes of y. How can I group them? Each number, okay. Now let's say z0 k values I have been grouping. Now when I'm taking z0, the another value from also must be from the same class. Okay, that is one condition. And then, hmm, now group them into modulo class of 3. One modulo 3 gives me 1, and this modulo this gives me 0, 0. Now next element which I choose of is if it is of the same modulo class, then with what elements can I group? I can group 1 with 15, 1 with 15, 1 with 15. The three groups formed here. 15 with 15, again two groups formed here, and then I cannot do the reverse because it's been already done. And then many one group is formed here. How many groups are formed here? एक के साथ तीन ग्रुप है, फिर next one forms two groups and then forms one group. These are six groups over here. And if I come to here, then if I take the modulo of them with, but one, they should be of same modulo class. So I need to form groups on these things. Like, what do I mean to say is, since 0 is equal to 2 minus 0 mod n, so there is no other option than grouping within themselves. So, how many groups can I form if there is one element? Actually, what I meant to say is, let's say I form group with this thing, group with this thing, and group with this. Only three groups are formed here, and same is the case applied here. 14, if I take modulo, what is the number which I need to take modulo? I think it is 2, I believe. No, it's 3. 3 modulo 14 is 12, and it's 2. It is 0. It is 0. It is 2. It is 2. Now, how many groups? One group is possible here. Two groups are possible here. Another group is possible. एक, दो, तीन, चार. 4 plus 3, 7 groups. Okay, this is how we arrive at the answer. Okay, how can we form it now? Now, this is the case where both the groups were the same. Case when 0 is equal to this thing. Okay, when I mean, whatever the I model I'm taking is equal to n minus I model. Now, this thing will be until n by 2, which is 0, 1. Okay, I think I need to go for other test case. Make it more clear. Modulo classes are formed till m by 2, so this to be done till m by 2, and no need to do about n by 2 things. Another thing is how will you find number of groups formed here. So the number of groups is formed here is 3C2 and into n minus 1 by 2. Wherever the frequency is greater than 1 into 1 minus 1 by 2 is 0. So now this frequency into n minus 1 by 2. So 3 into 3 minus 1 by 2 is one thing, and same is here as well. 2 into 1 by 2 plus, and there's another group of zeros, which is 3 into 2 by 2. It's 5, and right, how is it 5? 3C2. 3C2 is 3 into 2 by 2 plus 2C2. 2C2 is what? 1. 3 plus 4. And 2 into 1 by 2 is 1 plus 3 is 4, 4 plus 3 is 7. Now let's just try with another example actually. When we don't have the same classes, oh, I mean to say that thing. Because let's say one class is this thing, and one class is somewhat, I mean, let's say 6, 5, 2, and 1, 2, 7, 4, 9, 6. Then what are the classes formed actually? I have done it in the paper one. Okay, now I'm unable to find it. Okay, that I found. So if I group them into modulo classes, modulo class 0, this is something empty, and this is 1 comma 6, this is 2 comma 7, this is empty set, and this is 4 comma 9. Fine. Now, these are the groups. Let's say I need to take group. I'll be iterating from I is equal to 0 to I, then equal to m by 2, I plus plus. 5 by 2 is 2, 0, 1, 2. So I'll be checking for class 0, comma 5 minus 0 model and 1 model, comma 5 minus 1 model, and then 2 model, comma 5 minus 2 model. And then rest of the values will just go on repeating. Now let's have check 0, comma 5 model. In this class, oh, okay, it is again 0, the same class, and it's referring to the same class, so I don't need to check for this thing. And also it's empty set, okay. Now moving on to this one. If I move to this thing, I need to check this thing with 4, okay. That one is this thing and that is this thing. How can I group them? What did I just do earlier? I forgot. 1 comma 6. No, that 4 is 4 comma 9. Now what I'll be doing is I'll just taking modulo 2. Modulo y actually. I mean, this is 1 and this is 0. And now I'll be taking modulo 2 of this thing. Now 4 modulo 2 is 0. So I'll find number of zeros with this thing. If there are number of zeros, I'll be multiplying with those zeros. So count of this thing 0 will be added to my score. And now this thing is 1 plus count of 1. Okay, this is how grouping happens. And then I'll be getting answer as 2. 2 will be scored here in this case. And in this case, one set is empty, so there's no use of checking. Moreover, if I see 2 comma 7, one is modulo 0, modulo 1. Actually, I need to check self grouping and other grouping as well. Because let's say there was another value, which is let's say some 7, or let's say some 8. It gave me 0. I mean, leave the first condition, let me check on second condition. So then they both self grouping also happens here. Frequency A of each element into m into m minus 1 by 2 happens here as well. And also I need to create a map for each iteration, I believe. If I go for 9 for 9, and if I go, I'm taking this 4 9, I mean, self elements might be found, and then other pairs as well. Self pairs plus other pairs. So this will be map 1, and this will be map 2. What if I take combined of them actually? What do I mean is, let's say there was 1 0 0 here, 1 0 0, then basically how many pairs? If I combine those pairs, what I'll be getting is, how many pairs will we get? 2 C2 is 1 plus 4 C2. 4 into 3 by 2, 6. 7 pairs. I mean, I'm not talking about this case, but in general, let's say I'm 1 0 here and 1 0 here. Then if I go 1 0 1 0, 1 plus 1. Okay. So I just need to add the frequencies of modulo classes. Fine. In the both the modulo classes. And then what I'll be doing is, I feel the rollout we're doing this, but I just need to tolerate. Fine. Now what I'll be doing is, for it I is equal to 0, I less than or equal to n by 2, I plus plus. Also, there is one case which I need to check is if this thing is equal to this thing. If both the modular classes are equal to each other, then what I need to do is 1 0 0 0. How many pairs are formed? I need to do only single time, only single. I need to consider only single to be considered. Else, I need to consider both pairs union. Okay. Now, M is nothing but X actually. Okay. Now, what I'll be doing is, since I'm doing model of the classes, actually, I need to create one for each new iteration. What is time complexity of inserting in map? Log n, that's really good, actually. Okay. In M1 and M2, I need to see. Hmm. I'm taking X with this thing. Actually, it is I modulo X, and then this is X minus I modulo X. Okay. Now, what we are doing is, if I M1 is equal to M2, this case, check for one pair only, else for auto IT is equal to V of M1. M1, and then for auto IT is equal to V of M2. Fine. Now, what I need to do is basically count of IT plus plus, and the same thing applies here. Count of IT plus plus, and I'll be defining number of pairs here as 0. And now, what I'll be doing is I'll be iterating through the map. I think we did consider time complexity. There will be issues actually with the time complexity. MP plus or equal to IT minus 1 divided by 2. Okay, IT dot second, IT dot second. This is the number of pairs formed only for one array. What is the time limit actually? 2 seconds. Hope it runs. M1 M2 equal to M2 matlab I'm going referring to the same pair only. Okay, then what I'll be doing is by 2. Okay, let's see. I'm really having a fear that it won't run, but I must just. But maybe I've got something to say. It's a sick term error. Maybe it has exceeded the time complexity. Let me just put if it is not empty. Why is it sectum? Index, inner index, y, index, y, and then I'll see the array 1, 6 by 2, 1, 2, 7, 4, 9, 6. Oh, nice joke actually. I feel the life is the life. Okay, let's see how is the solution being done. I don't want to watch the whole video. What does this dark green mean? I mean, the same for the previous video was something light green. Oh, it was the same, the dark green. I think it's the truly discerning pupil. And this thing is specialist. It's kind of nice. And I mean, this thing. Okay, why did we use the candidate master? And this thing. Oh, video coming soon. What about the solution? Maybe someone might record and just put it there. DFS is adjacency list implementation of graph. I'm not good with the basic array implementations. How will I do the graph? Okay, let's read the editorial. Make equal recovering, make equal again divisible. Is it a div? Oh, it's a div 3 contest. Since A plus B follows the table moving with Z plus the table someday. If you are not getting a different just for some simple following criteria. I less than J, A mod X is equal to X minus M mod X. I to throw from momentum counter elements of specific place. Use a map on the graphics. What did it do? With anything. I mean, let's see his approach only. What is his approach actually? Because grouping is happening here also. He can pairing. Group the array element by remainder modulo y. Then for each group, analyze how to satisfy the first condition. The first condition is to be on the modulo. First condition is on the modulo x plus y to be divisible by x. So why should I take modulo classifier for the second condition? I mean, modulo support where is actually for each group analysis first condition. Group elements by a modulo y, count a modulo x in each group. Pairs form with remainders. Sum to x are 0. I think that was what I did. First I took a modulo x in each group. Then I have group, then ai modulo y is each group. Pairs form with remainders. Sum to x or are 0. Yes, yes, that is what I have done. So reminders is 0. This is one case. And if it forms a sum, okay, 1 minute. I need to put back IT, not x. 1652 127. Okay, and this target simple loop. Rep I command repetition. Yeah, I. Okay, no problem. It's a TLE fine. 1 to 0 and discount. Okay, then this thing and this thing. 0, 1, 2, 3, 4. Okay, map count m1 is equal to I modulo x. That is when remainder is 0. Hmm. Wow, I'm saying first time. Map of vectors. Map of vectors. When modulo class में storing is happening, big of login and login. Answer equal to 0. Got the vector of elements. Map to store when divided by x. Why is doing on the basis of y, then he's doing basis of x. But I'm doing the reverse. First I'm classifying on the basis of, then I'm storing on the modulo classes of y. Then I'm forming pairs. Why is this going wrong? Okay. Memory limit exceeded on test 8. Time limit. So the other, no, it's memory limit. Okay, how can I fix this thing? I just need to think about. Because I'm just consuming so much, so much, so much, so much. In the code is allocating the phrase are not correct logically. Okay, fine, let's just try it. The solution also use the map and comma vector of it. Use something like. And how do I push back elements? Hmm. Failing on this test case. Okay, only one test case is being failed here. Oh, my laptop might drain. I'll just get my phone. Okay, fine. Before my laptop battery runs out completely. What I need to check is this test case is failing. What is the test case actually? What is the close? Leave it. Mm, 923. I think this is the test case. No, 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 no. No, 923 is 962 is failing. This is X and this is Y. Oh no, we'll check again. It's just frustrating actually. Check for one pair only. Maybe this is the iteration is doing something. But just remove this and then try running it. This test case is passing actually. What is the value of this is the extra test case which has been considered. So I need to just do this thing again. Whatever updation he has done, I need to do mine. So this is really awesome actually. I mean CP is something. Just, what is actually IT dot second? It's a vector. IT in vector. IT dot second is a vector actually. Oh, beautiful pair. If it's the even number of pair at that time, it both are equal. Or else, if it's a zero pair, I mean, my condition is just fine. Now check for one pair only. Okay. This condition is failing maybe. Minus 1 by 2. And count is equal to IT dot second. No, what is IT? IT is being done in MP1. MP1, MP1. Okay, where is IT? Okay, for every count, I'm counting the number of pairs.